Hello. In this video, we are going to talk about stairs. Let's start with the properties and components of stairs, and then we are going to look at into the steps, slope and riser height, stair forms, flight width, landing, stairwell and well hole, handrail and guardrail, and lastly, we are going to talk about how we can design stairs and how we can express our design decisions during drawing the plans and sections. So let's start with what are the basic properties of stairs. As you all are very familiar with now, uh, this is the category of the building product. However, we can use that in order to organize our design decisions. First, we can start making decisions about the building plans, its visual aspects, the envelope, and we know that it will hold the living spaces, closed or semi-closed or open living areas. And these are all for the user. First of all, protecting the user from all the negative features of the outside environment, like the rain, storm, or heat transfer. Based on the climatic conditions. Also, some of the spaces can be done to execute certain functions, such as preparing food or sleeping or having a shower or something. All these functions are executed by the building and units specifically, but they will be divided or managed by different elements. These are the integral products. They can be formed by combining the materials, pieces, and components so that uh, these elements will physically meet one or some of the functions of these buildings. These functions, either protection from noise, protection from heat transfer, protection from cold, or specific functions such as preparing food, taking a shower, etc. These are the building elements. We have lots of different examples, such as walls, roofs. These are the subjects for our next semester. Hopefully, in spring semester in building science 2, we are going to dive into details of these elements. And this semester, we did the building structure, floors, uh, and now we need a spatial element so that the user can circulate through different floors. Uh, if they're on the ground floor, they need to go to the first floor, so we need stairs. Uh, but we can say, instead of stairs, we can say vertical circulation elements, because stairs is one of the options. We need to provide means for transport from one level to the other level for the user, and stairs is only one option. There are other options such as ramps or elevators, and hopefully next week or the week after that, we are going to look at the details of ramps and elevators too. But today we will the subject of this video is about stairs. Besides the function, stairs properties such as form, colors, etc. These are also important in terms of designing the space, because as you can easily understand, this space, this volume, will be created by many different things, and stairs are a part of that. Uh, Here are some very nice example in my opinion. So if you have time, you can see the name of the architect and the name of the building. You can search for that and try to understand how the architect designed that building, these spaces, and the stairs as a part of these uh, spaces. Oscar Niemeyer is one of the best examples, in my opinion. Here, the Minister of Foreign Affairs in Brazil, uh, that's one of the good examples. Also, I really like Carlos Carpa's elevator showroom that stairs. Uh, in my opinion, it's like a sculpture. not just for the indoor spaces, but for the facade of the building, for the outdoor spaces that can be used as a design element as well. Uh, this is what we call a space. Of course, obviously, it's a volume that we occupy, and we spend some time in that volume, uh, either a short time or a long time, and we do certain activities. We execute the space can be for specific functions, such as this one here. We can take a seat, we can work. Read, write, and watch the view. We can spend hours in there, but there are some volumes, such as that corridor. Uh, it's a volume. It's made out of these physical elements. However, we cannot call it like a space, not exactly like the one on the left side. So these are called non-spaces. It's just a passageway. You don't want to spend time in there. You don't want to sit there and read a book. It's uncomfortable. You just want to pass it through as quickly as possible. That's one of the examples of null spaces. Uh, you cannot uh, have a space in the common sense in that volume. Another example is this. These checkout desks. I'm not sure what they are called in English, but again, so much chaos, narrow alleys, corridors, and you don't want to spend some time in there. You can't use that volume as a space in the common sense. You just want to uh, be finish your shopping as quickly as possible and get out uh, fast. Stairs is something like that. You don't spend time in a staircase. You don't step here, stand here for a while and watch something, a nice view, or you don't read a book. It's kind of create this volume. Kind of creates a non-space. However, if we design it in a different way, and that's one of the good examples of David Chipperfield. This staircase is in the heart of the building, and its function is not just to provide means of transport in different levels. As you can see, it has spaces. It's created, it's designed to have living spaces. So that's, in my opinion, is one of the good examples of that design, and also the color, the shape, the location of that area, right in the heart of the building, and the contrast between these corridors, levels, and its color with the huge volume that this staircase creates. Uh, very important in my opinion. We can provide the same thing not in a large building, but in a small room or a space as well. When we do stairs, we can create different levels of usage, and this whole volume can be used more efficiently. Like all the other elements, stairs has their own components, and like all the other elements, they need to be integrated with uh, first of all units, and then floors, obviously, because that's the main idea here, main goal here. And since we are going to step on these elements, we will be on these elements. We are going to carry stuff on these elements. That means we are going to create loads, and these loads needs to be transferred safely to the ground, that the design of the staircase needs to be integrated with the building structure, because those loads that are applied on the stairs will be distributed to will be transferred to the structural system of the building, like the beams in the first floor. Some portion of the loads will be transferred to the beams of the first floor, and they are going to transport their loads to the columns, and some portion of the loads of the staircase will be port to the beam here at that level. Again, they will be transferred to the columns of the foundation, maybe depending on the level. If this is a ground floor and there is no basement floor, then we know that we have learned that there will be foundation columns. So the loads will be transferred to those columns. So designing staircase needs to be, we need to be careful about these decisions. We need to make decisions about its appearance, its geometrical form, its colors, its location, and its relationship with spaces, floors, and building structural system, including the foundations, in order to provide a nice load transfer. Uh, Okay, let's take a look at the components. This is a typical staircase, and we can see different parts. First of all, the basic component of a stair is the step. In Turkish, we call it basamak, and there are two surfaces for a step. This horizontal surface that we step on, that our feet touches, is called a tread, basış in Turkish, and there is this horizontal height, vertical height, sorry, the vertical height between threads, different levels, and that's called a riser, rıht, in Turkish. Uh, all these steps create a flight, merdiven kolu, a flight of stairs, and this horizontal small floor area is called landing, sahanlık. Uh, that part that we hold when we are climbing up or going down is called a handrail, küpeşte, and that surface can be created with straight lines like that, or that there can be a plane, a solid plane. That surface can be full. It's called a guardrail, korkuluk, and these are the basic components. And of course, stairs will be connecting two floors like that in different levels. And we are going to start from this yellow lower floor, and as we climb up the staircase, our goal will be to reach to the upper floor, the green floor in this example. However, right now it's impossible because it's blocked. If I continue climbing up, I will hit my head. So I need a gap. There needs to be a gap like that in the upper floor, so that I can climb without hitting my head. Uh, that gap will create a volume like that, a huge volume that combines these two different floors. Uh, and in this example, there are only two floors. If it's a multi-story building, then there will be lots of other floors. So this volume will be so much higher. It connects all these different floors. And there's a name for that volume. We call it stairwell, merdiven kovası in Turkish. And this volume, the stairwell, will be occupied with the stairs itself. So some portion will be filled with the staircase, but there is still some portion that is empty. Uh, and when you're on the top floor and when you look down, you will see the bottom of the building. It's just one empty, huge uh, volume. and it's called, this empty part is called well hole, or kova boşluğu in Turkish. So the whole volume is called stairwell, merdiven kovası. This empty portion, which is not occupied with the stairs itself, is called well hole, kova boşluğu. So these are the basic terms and components that we need to learn. And we are going to take a look at them one by one in detail. And of course, since there is this volume, there is this emptiness, it can be called a gallery space as well. When the user is on this floor, on the upper floor, there is a risk for them to fall down. So we need to protect them with the same type of guardrail and handrail as well. Same principles are applied. We don't want our user to fall from the side of the stairs. So we design handrails and guardrails to protect them. And same principles can be applied here. We don't want our user to fall down from the first floor, so we can design the handrail and guardrail as well. Let's take a look at the details of the steps. What are the properties of steps? As we just learned, they include a vertical surface, which is called a riser, and a horizontal surface, which is called a tread. Riser, rıht, tread, basış. The corner of a step where the riser and tread are met is called a nosing. So they create a corner which we call a nosing. The dimensions of risers and treads in a stairway should be appropriate to the user movement ability. We need to make proper decisions so that users can use the stairs, can take the stairs without a risk, without falling down. Uh, to avoid the contact of the heel with the riser, when we are stepping down, when we are going downstairs, our feet will move like that, and the heel may touch to the corner, that nosing part, and that can create a risk of falling down. We can either design a riser with a sloped surface, or we can create something that we call protrusion, uh, or we can have stairs with open risers without any risers. So the sloped surface can look like that. With this inclined surface, sloped surface, we can create a space for our heel to move easily. Uh, and protrusion is something like that. It's not an inclined space, but there is this a little bit projection in the nosing part. So again, when the heel moves upwards, there is this space so that there's no risk of falling down. Or we can have open risers, açık rıhtlı merdiven. That vertical surface, riser surface, is absent. There is no surface there. These are three options that we can make. We need to make decisions about the sizes of these tread and riser surfaces. First of all, in order to make the decision about the riser height, we need to know that a normal, regular person without any health conditions, a grown-up, what's the maximum height that that person can raise their feet, and it's maximum 31 centimeters. That's a standard, of course. That depends on the user. If the user is short or tall, or different races has different abilities to raise their leg. So that's a standard height. Based on this maximum height of 31 centimeters. We can make decisions for the riser height in between 10 centimeters to up to 20 or 21, either 22 centimeters, and that will depend on the user. If we are designing a staircase for children, then we need to go smaller, obviously, because of their height and ability to raise their leg. If we are designing for people who has walking disabilities, walking problems, and again, we need to prefer a shorter riser height. And we can make decisions based on the properties, biological properties, and other functional properties of the user. And what about the tread width? In normal horizontal surface with the normal steps, again, a standard person, uh, each step has 75 centimeters apart. There is this gap. However, it's decreased if you are on an inclined surface. If you are climbing on a ramp, then this gap is down to 65 centimeters. So based on these calculations, these standard measurements, we can say that for the stairs, the maximum ability for the gap for our feet to create the gap is the maximum number is 63 centimeters. So based on this fact, we can have a tread width approximately for 30 centimeters. Uh, Riser height can be between 10 to 20, 21, 22 centimeters. Tread width should be 30 centimeters. It can be 29, 31, but in that average. And the decisions about riser height and tread width will create the slope or pitch of the uh, stairs. And it needs to be, again, appropriate to the user and the function. Uh, these dimensions of risers and treads, the stairs have a certain slope, which can be indicated by the angle or a percentage. Uh, Here we have a staircase, and this angle between the horizontal floor surface and the inclined lower surface of the stairs, let's say it's beta, uh, we can indicate the slope or pitch of the stairs with this angle, or we can use percentage. In order to do that, we can imagine, we can create an imaginary 100 units. It can be centimeters, meters, it doesn't matter, but it needs to be horizontal. And then we go straight up with a perpendicular line, imaginary line. Let's say it's X units. Again, they need to be in the same units. So if you imagined 100 centimeters, then this will be X centimeters. And we need to connect these 2 points. The first point of the horizontal line and the last point of the vertical line, perpendicular line. And that inclined line will give us the slope. So slope of this line is X%. We can easily say that. We can determine the pitch of the stairs either with this angle by expressing or determining the angle, or the slope in percentage. We can say that the pitch of the stairs is X%. Here, there's this example. If we have this stairs, or it can be a ramp as well, an inclined surface, it doesn't matter. So this horizontal length is 100 centimeters, and this uh, perpendicular height is 6 centimeters. Then the slope of the surface is 6%. We can say that. As the angular percentage increase, the stairs become steeper. like that. Uh, and we can easily say that alpha angle is bigger than beta. Uh, and it creates a steeper stairs. Uh, Same with the percentage. Let's say we have y units instead of x units, but the horizontal length is the same. It's still 100 units. This time we will have y%. We can easily say that y% is steeper than x%, like that. Uh, However, as the angle increases or the percentage increases, as the stair gets steeper, it becomes harder to climb or go downstairs. Even if there is no risk, physical risk, psychologically, it creates a psychological uh, problem, let's say, there's this risk of falling down. The slope should be indicated according to the function of the building, the properties of the users, and the area available. In order to make a proper decision for the slope or pitch of the stairs, we need to keep in mind that the building function, the properties of our users, and the space, the area which is available for the stairs because it will occupy a space. We can have different angles, different percentages. Here, let's say that this angle is 20 degrees and that angle is 60 degrees. That's the minimum and maximum angles that we need to prefer for stairs. Any angle in between 20 and 60 degrees can be called a stair, uh, like that, with, of course, different uh, slopes, different pitches. Uh, if the angle is lower than 20 degrees, we should not design stairs. Instead, we should either design ramps or escalators, uh, like that. Uh, and if the angle is more than 60 degrees, in between 60 and 90, then it's called ladders or rope ladders. It's the 90-degree version. Obviously, you need to use your hands to climb there. And there's this line of 90 degree. On the other side, there is elevator. It's a cabin that we step in and it moves vertically. It carries us vertically in between different steps, floors. So the slope of the stairs, as you can see here, it can change. It can be 25 degree, 30 degree, 36 degree, something like that. As it gets steeper, uh, it becomes harder to climb. It creates a danger of falling down, a risk of falling down. However, it will occupy a smaller space, which means that there will be more area for the other functions, for the usage, other usages. Uh, it will be better for us to keep our stairs in between 25 degree and 36 degree. Uh, it will give us the optimum thing. Uh, Here, as this slope gets steeper, it will occupy less area. It's good for the space usage, but it creates a risk of falling down, and it will be hard for some users to use the stairs, like children or elderly people. If we have a very low step, a very low angle, then it will be easy for everyone to use the stairs, but it will start to occupy so much area, and the other areas of the space will be occupied with the stairs. So the optimum level for the optimum level, this part here, angle in between 25 to 36 degrees uh, can be more appropriate. And there is this formula that we can use. We can have one thread and add two risers to it, and we want it to be in between 60 to 64 centimeters. If we use this formula, then our riser height and thread width will be proportional, and the stair slope will be in between 25 to 60, 36 degrees. Also, we can use this chart. Uh, you can take a look at this chart whenever you need it. You don't need to memorize it, obviously. And depending on the function of the building, you can pick a proper riser height from this chart. If you are designing a monumental building or kindergarten, the riser height should be maximum 12 centimeters. For primary schools, it can be in between 13 to 14 centimeters. For public buildings, such as courthouses, municipality buildings, uh, buildings like that, the riser height can be up to 15 centimeters. Residents, apartment buildings, multi-family houses can be up to 16 centimeters. Private houses can be up to 19 or more, depending on the user, because in private houses, the users are certain. There are certain people, and if those users uh, doesn't have any problem with their feet, then they don't have a walking disorder. They are not old. They are not children. Then we can go up to 19 centimeters or more. But obviously, if there are children, depending on the age, we need to decrease the riser height. That's why kindergartens or monumental buildings or public buildings have this number for the maximum height, because any person, old people, disabled people, children can walk into those buildings. So we need to be careful about the riser height. Uh, if the user is healthy, they're adult, they don't have any problems, if the space is going to be rarely used, so the stairs will be rarely used, and if the user will not carry any heavy stuff, then we can go up to 22 or 23 centimeters. But we need to be very careful about that riser height. Uh, Obviously, we need to take a look at the properties of the user. Age is a specific determinant. Here we can easily see, because of the age, the height of the user, their sizes of the feet, leg will change. Uh, it will be similar with the older users, elderly people, and we need to take a look at their movement ability. If they need walking aids, like that, or we need to look at the activity as well. If they are going to use the stairs very fast, if they need to carry stuff, big stuff, heavy stuff, and during this carrying job, they won't be able to see what's in front of them, then the riser height needs to be shorter, obviously. For safety, all risers in a flight of stairs should be the same. Uh, we shouldn't change the riser height, and of course, the width of the threads should be the same as well. This is a very bad example. It's very dangerous, because when we are using the stairs, we don't realize what we are doing. It's just a muscle memory, an automated movement. And if there are differences with the riser height or step tread widths, then people will stumble. They can fall down. It can be deadly. They can break their head or neck, uh, like that.
Brazil's iconic Maracana Stadium has one small defect. Can you spot what it is? All these people are tripping over the same step.
So it's
It's
very
Brazil's
dangerous. We need to be careful about that. Uh, there can be different forms, geometrical forms for the stairs, and we have some common types. Um, of course, the form, the geometrical form, is directly related with the uh, number of steps, the riser height, tread width, and the flight of stairs. That's a straight run stairs. Tek kollu in Turkish, tek kollu merdiven. It doesn't matter if it has a landing in the middle or not. Uh, we take the stairs without changing any directions. That's why we call it a straight run uh, stairs. Uh, there can be different examples of it. Here we have a quarter turn, uh, and it has two flights of stairs, obviously. And when you take a look from the top, you will see an L shape. So in Turkish we call it L biçiminde 90 derece dönen iki kollu merdiven. A quarter turn L-shaped stairs. An example is this. And of course, there are two flights, but they don't need to be exactly the same. One flight can be shorter than the other one. They can be equal, like that. Or instead of a landing, corner landing, we can have winding stairs. These are called winders. We can have steps that allows us to turn 90 degree. Uh, that's the example of that. Winder stairs. Or we can have a half turn. The top view will give us a U shape, which allows us to change direction in 180 degrees. And there are two flights here. U biçiminde 180 derece dönen iki kollu merdiven. One example with the landing. The same thing can be applied here. There are two flight of stairs. They can be equal. The gap in between can be wider or shorter, or one flight can be shorter, the other can be longer. And like the quarter turn, instead of landing, we can have winders as well. Again, those steps led us to move and turn 180 degrees while we climb up or climb down the stairs. Uh, Instead of two flights, we can have three flights. Again, it can have this U shape. It can allow us to turn for 180 degrees. We can have corner landings, or we can have winders as well. Or we can have a circular staircase, dairesel merdiven. Uh, like that. Here we have two radius, one central point, one center. This first radius, that center, this first radius determines the well hole, and the other radius uh, is the end of that flight. And there is this distance in between, and that's the flight width, the width of the flight. Or we can have spiral staircase, sarmal merdiven. They look like each other. There's one specific difference. Uh, Here we have one central point, and there is no gap as a well hole. Only one radius. Here that gives us the width of the flight. That's it. This center is also the endpoint of each step. Uh, and these are the basic shapes that we can prefer, or we can, of course, design our own shapes. We don't need to pick one of them. These are the stereo. Let's take a look at the dimensions of the flight. How can we determine these dimensions? Uh, a series of steps on a row is called a flight of stairs. We know that. So merdiven kolu in Turkish. Here, this is one flight. That's another flight. So we have two flights of stairs with a corner landing here in this example. For user safety, a flight of stairs must have at least three steps, or otherwise users may not realize that there are steps. They may trip over and fall down. Like that. If we want to create its stairs, it doesn't matter. It has one flight or two flights or three flights. Uh, that stair, that one of the flights needs to have at least three steps so that users will realize if we do only one step or two steps, there's this risk of not realizing and they can trip over and fall down, and that can be dangerous for the users. Also, we need to consider people with walking problems or carrying stuff. So we created these three steps. But there can be people who needs to use wheelchair. There can be people who needs to use a walking stick or some aids, walking aids. There can be people who needs to carry baby strollers or heavy luggage or things like that. So instead of creating of these steps or addition to that steps, we can provide a ramp. It will be easier for them to move. And if you don't need three steps, then again, instead of creating a stair, we can design a ramp. For one step or two steps, ramp will be better. Ramps will provide easier access for wheelchairs, for people who carry heavy stuff with wheels, uh, and so on. Uh, the width of a flight can be determined according to the number of users. That's what we call occupant load. User properties, safety requirements, which are related to the function of the building. The width of the flight is this size. How many people can use the stairs simultaneously at the same time? If it's a private house, then probably only one person will be using the staircase at the same time. Uh, However, a public building, there can be many people walking side by side, either going upstairs or going downstairs. So the width needs to be determined accordingly, according to the number of user, uh, possible number of users that can use the stairs simultaneously. Also, what are the user properties of the users, such as age, health, or job? Let's say there are users, elderly users, and they need help while going upstairs or downstairs. So there's this person whose job is to support them, then it means that stairs will be used by two people at least, then the width needs to be calculated accordingly. This can be valid for kindergarten children as well. They need to be chaperoned while they are using the stairs by their teachers. Again, we need to take it into consideration. People with walking sticks or people who carry stuff, either their children or heavy boxes, or In some buildings like restaurants, hospitals, hotels, people will be carrying heavy stuff like food trays or dirty clothes, or so on. Then we need to take those into consideration because the width, if the width is not enough, then they will have problems. They can hurt their hands or they can fall down. These things can fall down. What will pass through the stairs other than people? Uh, we need to consider all the scenarios. People will be moving in and out of the buildings and they will require their furniture. Some of the furniture can be big. So other than people, these big furniture needs to be moved through the stairs in some buildings. So when determining, making decisions about the flight dimensions, we need to take in those into considerations. And the last thing that we need to think about is the emergency. During the emergency, all the people will be directed towards the stairs. During a fire or an earthquake, elevators are dangerous because they rely on electricity and we shouldn't use the elevators in those conditions, but we need to evacuate the building as soon as possible. That means that all the occupants of the buildings will be directed towards the staircase, so they need to move fast. This width and other dimensions of the stairs needs to allow that. We can calculate the required width like that if there are no special conditions about the age or the function or carrying stuff or so on. Just a normal standard person, we can uh, accept that width of arms, the outer side of this arm and the outer side of this arm, this total distance is 60, and we can have 5 centimeters gap so that they don't hit their hand to the sides of the stairs. So for only one person, we can have 7 centimeters, 60 plus 10. If they are going to be carrying stuff, including the refrigerators or big sofas or any big furniture, we can add 30 to 60 centimeters. So we can have 90 centimeters for the width uh, uh, minimum. And if there are two or more people are going to be using the stairs at the same time, simultaneously, side by side, we can determine the required width by adding 60 number of people, like two people walking side by side, then 60 plus 60, the required width will be 120. If three people, 180, and it goes like that. Let's take a look at the properties of the landing. How can we make proper decisions? This is the relatively small flat floor area between the flights of stairs to provide users to rest or pause or change direction in this L-shaped example. That landing allows us to change our direction 90 degrees or 180 degrees, whatever. The width of the landing must be equal. It can be bigger, but it shouldn't be smaller than the width of the flight. So let's say this is A centimeters, then it needs to be at least A centimeters. It cannot be smaller than A centimeters, but it can be bigger, obviously. And that that's true as well. This is the example of Carlos Scarpa again. His stair design, that corner landing is one of the examples, and that's a very nice uh, design of I don't remember the name of the architect, but it's a residence, and it's in Ahmedabad in India. Uh, so this landing here, it's very nice. It's cantilevered. We can first make a decision if we do need a landing or not, and that decision can be made based on, again, the properties of our other decisions for the stair design. If there are lots of steps, that means that there is this height, a very big height in between these two floors. That means we need lots of steps, lots of risers, and the user starts to climb up the stairs, but they will get tired. If so, we can provide them a landing so that they can catch their breath. But if there are not so many steps, then we don't need to do that middle landing for a straight run stairs. And the number can be calculated based on the shape of the stairs and the let's say the maximum number of steps without requiring a landing can be up to 16, 17, something like that. If you are designing a stairs that has more steps than 17, then you can provide them a landing. Uh, and also the landings can be used to execute other functions. We had this example of David Chipperfield previously, and this is an example I'm guessing from a university. That stair hall uh, is used as an amphi as well. The sizes of the landing is important if there is a door adjacent to the stairs. This can be the main entrance door or a door for a room, an indoor door. It doesn't matter. This is very dangerous. We shouldn't do that because let's say there's this person who wants to step out and they open the door. If they don't see the steps, if they don't see there is this level difference, they will fall down. So it's very dangerous. We need to provide a landing. Uh, and while doing that, while determining the required sizes of the landing, we need to take into consideration that the movement of the door. If it moves outside, and if there is a person in the outside part of the door, then the door may hit them, and it can cause them to fall down. So this movement of the door, let's say it's 90 centimeters, the door is 90 centimeters, so the landing needs to be bigger than 90 centimeters. We need to provide an area at least like 40 or 50 or 60 centimeters so that the person can stand there without being hit by the moving door. Uh, let's take a look at the stairwell and well hall. What are their functions? What are they for? The vertical distance between overlapping flights of stairs or between a floor and the stairway should be enough for a person to use the stairs easily and comfortably. Uh, that's what we call a overhead clearance. We don't want our user to hit their head. Here we see there is a gap, but it's not enough. We should have the gap right over the stairs. The upper floor should not block some portion of the stairs, some steps of the stairs. The whole area over the stairs should be open. In Turkish, that's called başkurtarma. For public buildings, there is this limit. It needs to be minimum 2 meters and 50 centimeters. For residences, it can be for maximum minimum 2 meters. But I don't recommend you to take those into consideration because the head is not enough psychologically, or if you are carrying stuff, these limits will not be enough for you. Here, for psychological to use these stairs uh, easy psychologically, let's say, this height needs to be bigger than our head, our normal height. It needs to be more than this portion. When I raise my hand, I shouldn't be able to touch the lower part of the either the floor or the upper stairs, because it will be a problem when we are carrying stuff, or it will cause problems, either physical problems, we can hit our head, or psychologically it can be disturbing. We shouldn't do that. We should leave a gap right above the whole stairs, not some portion of the stairs. So these are very bad and wrong examples. Uh, Here we have an example. There is this upper floor, and we need to create this gap right above the stairs. That's called the stairwell. And it needs to be proportional with the shape of the stair. If we are designing an L-shaped staircase, then again, it needs to there needs to be a gap, and the gap should be right above the whole stair. Okay, like this. That's the area that's occupied with the stair, uh, and the gap is at least that big. We should never prefer creating a gap like that. We shouldn't say that is enough for a gap. That's enough for a gap. We shouldn't say that, because these first uh, 2 or 3 steps or 4 steps whatsoever, they are blocked with the floor this time, and there is this risk of hitting our head. So we need to clear the whole area above the stairs, uh, like this. A U-shaped stair, a proportional stairwell. Circular stair, again, a proportional stairwell, uh, like this. This gap is important. That's the stairwell, and some portion of that stairwell will be occupied by the stair itself, and there will be this gap. That's what we called well hole. So this is the well hole. Just imagine yourself, you are here and you are looking down, you will be able to see the bottom of the building, or if you look up, you will be able to see the roof. That's important for us. Again, we need to make proper decisions for that. Handrail and guardrail, why do we need that, and how can we determine their properties? If we don't have them, it's very dangerous. There is this risk of falling down. So we should always uh, create a solution. And creating handrails and guardrails are one option. That part, that elevated edge that we can hold, that's called the handrail, küpeşte. And this surface that prevents us to fall down, it's called guardrail, korkuluk. If we want, we can design them both. If we want, we can only have a handrail. If we want, if we can only have a guardrail, or we can have different solutions. There are different solutions that we can do. The design of handrail or guardrail must be compatible with the design of stairs and the space, obviously. Visually, color-wise, geometrical form-wise, that's a nice example. And this is also a nice example. Here we see only a guardrail, there is no handrail. We can say that this upper edge of the guardrail works like a handrail. That's where we can hold our hand. But the design is very nice. Here we see lots of lines and curves. And for the guardrail, they preferred glass planes, surfaces, to create a balance between all these movement, let's say. But if you have walls on the sides of the stairs, then obviously we don't need guardrails because it's already protected. We can have handrails depending on the properties of the user. If the user needs to hold somewhere while they're climbing up or down, for old people, for people who carry stuff, for people who have walking disabilities or children, then we can design only handrails. That's a design that can be designed in very different shapes, and even the design can be uh, mm, the part of the facade or the whole building design. Let's say again the same principle. Here we have lots of lines, lots of texture. In order to balance that, they created these transparent surfaces for the guardrails. Do we have to use that? Of course, we don't have to use that. We can have solutions. That example of Oscar Niemeyer, if you put handrails and guardrails next to these steps, then it will disturb all the design properties. Uh, Here we have a circular gallery space, and at the end, it's like the stairs are floating down like that. So you don't want any vertical lines here, obviously, but you need to protect your users from falling down. That's why there's this middle part. It's emphasized with this color, and these sites are projected uh, more than required so that it's for to keep users to go closer to the sites. If they don't go closer to the edge, then there's no risk of falling down. So that's an example. Or we can create surfaces. This is not a handrail, this is not a guardrail, and it can have different functions like these bookshelves or shells, or we can close that whole surface so there's no risk of falling down. Lots of different examples. Okay, now let's take a look. How can we design stairs? Let's have an example, and after that, how can we express these design decisions while we are drawing plans and sections? Uh, what's the way of doing proper decisions? First of all, we need to make, when we are designing stairs, it's not separated from the design of the building and the spaces. They are all integrated, so we need to make decisions all together. But when making decisions about the stairs, we need to make specific decisions about the riser height, tread width, the slope or pitch of the stairs, flight width, form, and things like color, texture, etc. And they depend on the user and their activities. We need to take into consideration the age of the user so that we can make proper decisions about riser width, riser height, tread width, slope, and flight width and form. Their health and movement abilities. They can be blind, they can have they need to have to use some walking aids or wheelchair. Also, we need to take into consideration their activities. Are they going to be carrying stuff, either heavy stuff or big stuff, like furnitures, big furnitures, or are they going to be carrying their bicycles, these strollers? I think they are called strollers, or luggages like that. Or in some buildings, we need to take into considerations these gurneys. Doctors, nurses, or healthcare workers, they need to carry these gurneys on patients. In some buildings, people, waiters needs to carry heavy food trays or dirty plates or food boxes. Uh, in some buildings, like hotels or hospitals, again, they need to carry pillows, sheets and dirty clothes or garbage even. So we need to first analyze the user, their activities, the function of the building, and then we can make proper decisions about these properties. Uh, let's have an example now. Let's imagine that that's a building, a very simple building that we designed. It has 2 floors, as you can see. It has a very small garden area. There are 2 suites. On this side, there is an entrance terrace with 3 steps, an entrance door. This ground floor will be used as a shop. And the other side, this facade is directly right on the pavement walkway. And there will be a first floor. So for the first floor plan, we need to cut cut the building horizontally at this level. The level is the eye level of a person who stands on the first floor. So it's been cut. And we elevate the upper part and we look down. We see that the first floor is a partial floor. So there is this void, a gallery space, so that the upper part of the building, the upper space can be integrated with the lower space, and the level is 3 meters. And if this is 0, 0, then it's +3. And this upper part will be used as an office. First of all, we need to design the stairs. First of all, we can make decision about the form of the stairs. We have all these options. And let's try some of them and see what happens, what we are face to face with. And while making that decision, we need to take into consideration the function of the building, the properties of the user, and the relationship with spaces, volume, and the area. Uh, you remember that the proper slope is in between 25 degree to 36 degree. If it's steeper than that, it will occupy lesser space. That means that there will be more space for other usages. It will be better for the space usage. However, it will be bad for the stairs. It will create a risk. And if we do the opposite, if we provide an easy run, that means a lower slope, then the risk of falling down will be lesser. However, the stair will start to occupy so much area that there is little space for the other usage, and the lower part will be used as a shop. So if we prefer a large stair, then it will occupy so much area of the shop, and there will be lesser parts, lesser areas for the other activities. So first, let's try straight run. That means that we can have a sketch like that, something like that. Let's imagine we created the straight run stairs. That means that we need to create a gap on the first floor. That means the usable area of the first floor will be will become smaller because we need that stairwell there. And the users, they will start walking here. They will take the stairs and they need to turn 90 degrees in order to reach the first floor, the office area. How about a half turn? We can locate our half turn stairs like that. And as you can see, we need a larger stairwell. That means both the first floor area and the ground floor area will be occupied so much with the stairs, and there will be lesser area for the other usages. And the user needs to walk a lot into the store, take the stairs up, make a 180-degree turn, and then they can reach to the first floor. The distance they need to walk is bigger now. How about a spiral staircase? As you can see, it occupies so little space. All the area, all the rest of the ground floor and the first floor can be used for other functions. It's good. However, again, based on the location, the user needs to walk so much, and it will be hard to climb up while turning upstairs. Uh, so, in my opinion, for this example, we can prefer the straight run. It doesn't occupy that much space, and it's relatively easier to climb, and it will be closer to the entrance door, so the user doesn't need to walk so much in order to climb the stairs. That's the decision about the form of the stairs. Now we need to make decisions about the riser height, tread width, and nosing type. In order to do that, we need to take into consideration the level difference between these two floors. It's 300 centimeters, and we need to make the decision about the riser height based on the user and the function of the building. Uh, the user, we need to take into consideration their age, their movement ability, and their activities. In our example, the lower level is a shop, the higher level is an office, and there is only one user. He's healthy, he's adult, he's not a child, he's not an older people person, and he uses this office space rarely, so it's not a very much used space. That means that he's not going to be up and down the staircase so many times during the day, and he's not going to carry any stuff. These are our uh, properties for of the user. So that means that since there is no health issue, since the person is a standard adult, and since the space is going to be rarely used, and he's not going to carry any heavy stuff or big stuff, then we can have a high riser height, like 19 centimeters, 20 centimeters or so, because the risk is minimum now. Let's calculate if the riser height is 21 centimeters. How many risers will there be? We can easily calculate that. We need to divide 300 centimeters into 21. That gives us 14.28 risers. That cannot be the riser number. We cannot have that much riser. Uh, but we can recalculate if there are 14 risers, we can have 14 risers, obviously. What will be the riser height? When we do the math, we will have a 21.42 centimeters for the riser height. That's something we can construct. We can construct that. If the height is not appropriate, what should we do? Then obviously we can increase the riser number so the riser height will decrease. Instead of 14 risers, we can have 15 risers. That will give us 20 centimeters for the riser height. So we can do these type of calculations in order to find the best option. And we can note these down. There will be 15 risers. Riser height will be 20 centimeters. Now let's make a decision about the tread width. We can use this formula, one tread plus 2 times of the risers. It needs to be in between 60 to 64 centimeters so that we will have this normal slope. Let's do the math. One thread, 2 times 20, when we subtract 40 from 64, then we will have 24 as the thread width. Is that enough? Let's take a look. It needs to be related proportional with the length of a feet. This is the standard shoe sizes. In Turkey, we use European style, so it means that a man who wears 43 number size shoes, their feet length will be 8 centimeters, and obviously 24 centimeters will not be enough. Some portion of their feet will be off the riser, and that's bad. So instead of this formula is it's not mandatory. It's created so that we can have our slope in between these angles. We don't need to take into consideration that formula and have a 24 for our tread width. We can change it, obviously. So instead of 24, let's think about the shoe size and the feet length. And as you can see, it's almost 30 centimeters. We should take 30 centimeters as the tread width. So let's note that too. Our tread width will be 30 centimeters. What about the flight width? That depends on the number of users. The again the user properties and if they are going to be carrying stuff and emergency. So there will be only one person. There won't be any other people using these stairs. He's not going to carry any heavy stuff. He's healthy. He doesn't need a walking sticks or a helper person or something. So we can have it minimum in the minimum. And as you remember, we calculated it based on the width of a standard person. That's 60 centimeters, and we have 5 centimeter gaps on each side. So 60 plus 10, 7 centimeters for minimum. If they were going to carry furniture, then we can add 30 to 60, and we will have 90 centimeters for the width of the flight. If there will be two or more people, then we can add 60 plus 60 plus 60 and the number of people, so that we will have 120 centimeters, 180 centimeters, or so on. In this example, we can have 7 centimeters. Do we need a landing? Should we design a landing? It was to provide users to rest or pause or change direction. Since we have a straight run stairs, they are not going to be changing in direction, and they don't need to rest or pause for only 15 risers. So we don't need a landing. These are all decided, so we can create our stairs like that, and we can position it like this. But right now, the user will hit their head because there is no stairwell on the first floor. There is no gap on the first floor. So we need to create the gap, and the gap needs to be proportional with the sizes of the stairs. We need to create that gap as big as the stairs. No portion of the stairs will be blocked by the first floor. So that's our stairwell. Also, we need well hole. So that well hole, for the well hole, we can have 10 centimeters for the minimum. This side of the floor, it shouldn't be adjacent to the side of the stairs. We can have at least 10 centimeter gap for the well hole, so that if we are going to design a guardrail, handrail, there is enough space for us to do the construction there. And here, these distances are important because our user will start walking here when they enter from the front door. First, they are going to turn 90-degree towards the wall, and then they need to turn 90-degree towards the stairs. So they need a space here, and then they will be going upwards in the stairs. And once they are on the first floor, they are face to face with this wall. Again, they need a space to turn for 90 degrees. So these measurements needs to be enough, and they shouldn't be lesser than 70 centimeters. Don't forget, this flight width needs to be the same with the this portion here. So let's take a look. That's 70 centimeters. We have now 2 meters, 10 centimeters. That's more than enough. That's good. And addition with the additional 10 centimeter well hole, we have now 8 centimeters. So this measurement needs to be at least 80 centimeters. Otherwise, once the user is here on the first floor, they are face to face with the wall. There's not enough space for them to make that 90-degree turn. So it needs to be at least 80 centimeters. It shouldn't be smaller than 70 centimeters. So these are our decisions. Now, to draw the first floor plan, this is what we need to do. We cut horizontally, and we see that these walls, that window at the back, and the wall that we removed in order to see the stairs, these are all cut surfaces, so we need to draw them with high line weights, thick lines, and when we look down, we will be seeing the upper surface of the first floor. It needs to be drawn with thinner lines because it's a thin surface, and we see the whole upper surface of these threads. So these are the threads, and these lines represent the risers. We don't see the risers, we only see their upper edges. So that's the first riser here, first riser, and then the second riser. There's 30 centimeter for the thread width, and it goes like that for 15 risers. And the last riser is the floor itself, as you can see here. Last riser is the floor itself. We draw that, and of course, we need to put the level marks at the beginning of the stairs and at the end of the stairs. That's mandatory. That's very important, so that people can understand there is this level difference here. We need to draw this middle line and put an arrow that shows the upper part. The arrow should always show the upper side. And to indicate the first step, we can use these two little lines, side lines here. That's the side of the stairs, as you can see. And here we have the side of the upper floor. And in between, we have our well hole, that's 10 centimeters minimum, 10 centimeters. We can write the name of the space and the square meter here. And for that part, it's way down low. We see the upper surface of the ground floor here. We can use gallery space. We can write gallery space. So that's our first floor plan. We see the whole stairs and the floor itself. Let's think if we need a handrail or guardrail. Well, where are the risks? What are the risks? Let's imagine there's a, don't forget, here we have the wall. We just remove the wall so that we can see the stairs itself. Let's imagine when we are going upwards or downwards, there's a risk for us to fall down at this side of the stairs towards the ground floor. So we need a guardrail and or a handrail on this side. When we are on the first floor, since there's this gallery space, there's a risk for us to fall towards the stairs or towards the ground floor, the entrance door. So we need protection on these two sides as well. We can design only a guardrail, we can design only a handrail, or we can do them both. So this is what I designed. I designed a handrail, and I attach it on the upper side of these steps with these sticks, vertical lines. So it sort of creates a guardrail as well. And As you can see, it starts on the first floor. It rises with the slope of the stairs, and then it goes sideways at this side of the floor, and it follows that side of the first floor and the front side of the first floor, and it's adjacent to this wall now, so no risk of falling down. Uh, that means on our first floor plan, when we look down, we will be seeing the upper surface of this handrail. We won't be able to see the guardrail, but we will be seeing the upper surface of the handrail. Here, it starts to follow and it raises next to the stairs like that. And once it's on the first floor, there's this 90-degree turn here, and then one more 90-degree turn so that it can follow the side of the first floor, and then one more 90-degree turn so that this front part will be protected. So that's the first floor. Now let's take a section, a section. As you can see, we start cutting here on this sidewalk, the street, the garden wall, the garden itself, the entrance terrace, this wall and windows here, ground floor itself. We cut through all the steps, some portion of the first floor, also the ground floor here, and this back wall, the sidewalk, and the other street. Uh, we can have our plan. We can draw our section line. That's the cutting plane that represents the cutting plane. And we can transfer all these information, all these widths in order to draw a correct section. The section will appear here. So I start transferring the sidewalk, that's the road. The sidewalk, it's 15 centimeters higher than the road. And then I transfer the garden wall, let's say it's 1 meter high. And then there is this soil part, earth. Then the terrace, that's the upper surface of the ground floor, 0, 0 level. And the other sidewalk and the other street. So these are drawn. I draw with thick lines because these are the cut surfaces. And then I transfer the wall window here. So there's this parapet wall, this window, and then the wall in between two floors, the upper window, and there's this flat roof with the parapet wall again. And at the back here, we have a window, this wall and parapet wall. And uh, here we can transfer this portion of the first floor. So it needs to be drawn with thick lines because it's cut again. And here we have a window uh, at the back. Now I transfer the risers one by one, and I know that each riser have 15 centimeter high. So these guidelines, using these guidelines, I can draw my stairs like that. And that's the lower surface of the stairs, and it's connected to the first floor. As you can see, there are no lines here. It's just one empty box with the edges drawn with thick lines. So these are cut surfaces. That's why we use thick lines. Now I draw everything that is being cut with this red plane. And now I can proceed to the things that I see. When I look towards this direction, there will be things that I see. First of all, this side of the handrail and guardrail, and that side of the first floor, I need to use thinner lines to indicate that these are seen surfaces, not cut surfaces, but seen surfaces. Again, I'm using my plan to transfer the side of the first floor, and then I use my plan to transfer the handrail, and I know that we have a guardrail in the middle of each step, so I can use my plan to draw the guardrails as well. First, this is the one that goes up, that is close to me here, and then once it's on the first floor, the other one is at the back. So I leave little gaps to indicate there is this difference. The this portion of the handrail and guardrail is at the back. All the things that I see, they are drawn now. I need to put level marks, the upper part of this window, lower part of the window sill, upper part, again, the upper side of the floor, ground floor, 0, 0, upper side of the first floor, upper side of the flat roof. So the section and the floors. Now, this upper side of the side wall, the lower side of the window sill, upper side of this window here, again, lower side of the window sill, upper side of the window, and the parapet wall here. I write the names of the streets, write the name of the spaces, and that's my AA section. And in order to emphasize the cut surfaces on the plan and on the section, I can have this hatch or I can color it for only the cut surfaces, the inside of the cut surfaces. Now let's draw the ground floor plan together. In order to do that, again, it's a horizontal section. Previously, we did the first floor plan, and it was the horizontal section at the level of the eye level of a person who stands on this first floor. So it's 3 meters. A standard person, let's say their height is 1 meter 80 centimeters, so their eye level will be approximately 1 meter 60 centimeters. So this level for the first floor plan, the cutting plane for the first floor plan will be approximately 4 meters 60 centimeters or so. That's the level that we do the horizontal cut and look down. In order to do the ground floor plan, now we need to move that cutting plane lower to the person, to the eye level of the person who stands on the ground floor. 0, 0. That means that the level of this red plane, red cutting plane will be approximately 1 meter 60 centimeters or so. As you can see here, it cuts through the stairs, the handrail and guardrail. This time the door and this lower window is being cut, and that is being cut. And this portion of the stairs and the floor will be above our head. We elevate it, we are in between, and we are looking down, and we need to draw what we see. We need to start drawing with the cut surfaces. Here, I draw the walls, the cut surface of the walls, the cut surface of the door and the window here, that door, that wall that we removed, the window at the back. I draw the cut surface of the stairs and the handrail, but I symbolize it. I use one thick line. It's an inclined line. It's very thick. It's inclined like that. And it symbolizes all these cut surfaces. And these are the things that are being cut horizontally. Now I need to draw what I see when I look down. I see the threads of these steps. Uh, it's approximately the 8th step that is being cut. So the first 7 steps, I see them. So I draw the risers and the threads. Again, I see the upper surface of handrail till it's being cut. And I draw my middle line, the arrow that indicates the upper surface, the first floor. And when I look down, I see the whole upper surface of this ground floor with its texture. So I draw it with thinner lines because they are thin surfaces. Uh, and on the outside, there's this terrace and 3 steps. So I draw their upper surfaces as the seam surfaces. I draw the upper surface of the garden walls and the sidewalks like that. There's this tree. Because of the height of the plan, the cutting plane, the tree trunk is being cut. So it's thick. and the rest is above my head. The rest of the handrail, the rest of the steps are above my head, so I use dashed lines to indicate that they are above my head. The first floor is above my head, so I indicate that with dashed lines, and as you can see, the handrail that follows the side of the first floor, it's above my head, so I use dashed lines to indicate that. As you can see, this middle line, it's also dashed, and the arrow is also dashed. It continues with dashed lines. And here, when I look down, I see the upper surface of the ground floor. This is still 0, 0. I need to put 0, 0 here at the beginning of the steps, but I cannot write +3 because I don't see it. It's above my head. When I look down, I'm still seeing 0, 0, so no need to put 0, 0 one more time. And the level marks, they should be in and out of the doors that connects outside and inside. So this is a door that connects outdoor and indoor environment. 0, 0, 0, 0, two sides. Again, here. And the level difference, 0, 0, -3. So this is the cut surface of the stairs. It is a symbolization. Uh, when I look down, I see these steps, so I draw them with thin lines. These are all above my head, so they need to be indicated with dashed lines. This portion of the first floor and handrails, they're above my head. They need to be indicated with dashed lines. That's what I see when I look down. The upper surface of the ground floor, it needs to be drawn with thin lines. Here, that's the whole 0, 0 level. We can compare these two. In the first floor plan, because of the height of the cutting plane, stairs are not being cut, they are seen. So I see the whole upper surface of the threads, the whole upper surface of the handrails, and the whole upper surface of the first floor. I draw them with thin lines, seen surfaces. For the ground floor plan, because the level of the cutting plane has been changed, stairs and handrails are being cut, and I symbolize it with this thick inclined line. These are all above my head, so I indicate them with dashed lines. When I look down, this is what I see, the whole ground floor, so they are drawn with thin lines. First floor plan, ground floor plan. I advise you to stop the video and do this with your hands, practice it, so that these principles are, uh, you learn these principles and you can transfer them to your own projects. This is how we can do the drawing correctly. Uh, let's do the BB section this time. As you can see, BB section is perpendicular to AA section. We are again cutting through these steps, and based on the position of the BB section, we are cutting through the first floor and the ground floor, and these side walls, this portion of the garden and the garden wall. Again, we need to use our plan and AA section to draw the BB section. We need to do that on a pure of Monge that system. Even if we use AutoCAD, it doesn't matter. We are using RT squares and set squares. You should do the same. Place your plan here, place your AA section here, draw that BB section line there, and transfer certain things from your plan, all the things that are being cut, like this garden wall, I transfer it like this, and I use my AA section to transfer the level of the garden wall. that's the ground floor and the soil in between, earth in between that garden area here. I use my AA section to transfer the level of 0, 0 here, and I use thick lines to draw the cut surfaces. And then I transfer that wall and this wall and the first floor from my plan. And for the levels, I use my AA section. I transfer the level for the first floor, the flat roof, the parapet walls. These are all cut surfaces, so I need to draw them with thick lines. And as you can see here, one, two, three, four, fifth step is being cut because of the location of our BB section. If you move the section line, then some other step will be cut. But here, right now, it's the fifth step. So I transfer the width of the stairs from my plan. I transfer the height of that cut step from the AA section. I draw it with thick lines. Here, that is where the handrail is being cut. So I transfer it from my plan, transfer the levels and draw it with thick lines. But the handrail in the first floor, next to the first floor, it's also being cut. So I use my plan to transfer its position, the AA section, to transfer its level and draw it with thick lines. The rest of the steps, they are being seen. I need to use thin lines now because they are thin surfaces, not cut surfaces. I use my AA section to transfer their levels. And the rest of the steps, they're at my back. I don't see them. I can indicate them with dashed lines. Again, I use my AA section to transfer the levels. Here at the back, I see the door and the window and this upper window here. Again, I use my plan and section to transfer them. Uh, I can hatch or color, do the same thing to emphasize the cut surfaces, only the inside part of the cut surfaces. I write the names of the spaces. I put level marks 0, 0 and +3 and +6 for the upper surface of the floors. Here, the lower side, upper side of the window, the level marks. The upper side of the parapet wall is here. And on this side, it's symmetrical. The upper side of the parapet wall, upper side of the window, lower side of the window, the upper side of that door, it's been given. Uh, and it's that. All the correct line weights, thick lines to indicate the cut surfaces. They are hatched. Thin lines that are to indicate the seen surfaces. Uh, and dashed lines to indicate the unseen surfaces with all the level marks and the names of the spaces and the people here. Uh, that's for this example. We designed a simple building, we designed stairs, and based on our design, we draw the ground floor plan, AA section, and BB section. Uh, First, always make the design, finalize the design in a 3D environment. You either use SketchUp or make a model, make all your decisions on the 3D environment, and then start drawing your plans and sections by using that 3D model that you have, so that you won't be having any issues. You can correctly draw all the cut surfaces, all the seen surfaces, and unseen surfaces. Plan is a horizontal section, section is a vertical section, and you should always start with the plan and then do your this section, use your plan, transfer the necessary information with very thin lines, barely visible lines, do your section like this. And for your other section, again, use your plan and your first section to transfer the necessary information. That's how you do that. Okay. Let's review the other types. So this was only one example. What if our straight line the stairs was designed like that with this upper floor? As you can see, the upper surface of the floor is reddish. the upper surface of the ground floor is greenish, and there is this straight run stairs here. The first floor plan will look like that. When I cut here at this level and look down, I will be seeing the whole upper surface of the stairs. I put my middle line. The arrow always indicates the upper side. I see the upper surface of the first floor. So it's reddish, and there's this well hole, and through that well hole, I see some green surface, the ground floor, the upper surface of the ground floor. Our AA section here, it cuts through this upper floor, the first floor, the lower floor, ground floor, yeah, green floor, and the whole stairs. So I cut the green floor here. I cut the stairs with thick lines. This part and this part of the red floor is being cut with thick lines. And when I look towards, I see this side with thin lines. But how about the ground floor? That means I need to lower the cutting plane here. I will be cutting through the steps. It will be something like that, and I will be looking downwards. So I symbolize the cut step with this thick and inclined line. This will be over my head. Uh, all these steps that I see when I look down, I see them, and I put my middle line with the arrow indicating the upper part. I indicate the first step like that. The rest will be above my head, so they need to be dashed. These sides of the upper floor, they are above my head, so they need to be dashed. The middle line and the arrow, it continues with dashed lines. And when I look down, I will be looking at the green surface. I don't see any red surface because our cutting plane is here and I'm looking down. So all green surface here. No green, no red surface. Red surface is completely above my head. That's the ground floor plan. What if we do a quarter turn? Let's do the same. First floor. When I look down, I see the red floor like that. I see the whole upper surface of the stairs, including the landing here. And based on my design, there is this well hole here in the middle. So I see green floor, and there is a side well hole. So I see that green surface of the ground floor. Let's draw the AA section. I cut through that red floor and it ends here. I cut through the green floor. I cut through the steps. I cut through the landing. So I draw them with thick lines. I cut through this portion of the red floor. And when I look towards, I see these steps. They are thin because they are seen. I see the side of the red floor like that. Now the ground floor, it's been cut at this level and I look down. That means this is the cut surface. It symbolizes the cut surface. Everything else will be above my head. So they will be indicated with dashed lines. I will be seeing this portion of the steps themselves. This is my middle line with the arrow with the first floor, first step. The rest will be dashed lines with the arrow. And when I look down, I only see green surface, no red surface. It's above my head, only the green surface. Let's do it with winders this time. The first floor, I see the red floor. I see the whole upper surface of the steps. Again, some portion of the green floor because of the well hole, and some portion of the green floor here in between these two sides because of the well hole. Let's do the AA section. I cut through this red floor thick. I cut through this portion of the red floor thick. I cut through this green floor and these steps. Here, the last step that is being cut is this one. and some portion of that step is being seen. So I drew it with thin lines. These three steps, they are seen, and this side is being seen. So because of the winding steps, these are both cut and seen. This portion is being cut and the rest is seen. That portion is being cut and the rest is being seen. Like that. How about the ground floor plan? It's approximately being cut here. Thick line symbolizing the rest is above my head. Straight line, middle line with the arrow. Rest is dashed. The middle part, middle line is dashed, arrow is dashed. The sides of the red floor is dashed. When I look down, I only see red, green surface, no red surface. Let's do this. First floor, I see the red surface. I see two flights of stairs, the landing, upper part of the landing, and the well hole. Because of the well hole, there is this green part, and here some portion of the green surface. And the section here, I cut the red floor and it ends here, this portion. I cut this portion of the red floor, it ends here. I cut through the green floor with these steps and the landing here. And the rest is being seen. I see the side of this other flight. I see the side of the red floor here. If you use your line weights, it will be easily understood which is being cut, which is being seen. Ground floor plan, it's being cut here, so symbolization, everything is being seen. Straight line for the middle line, arrow, rest is above our head, so dashed lines, including the middle line and the arrow, these are dashed lines. Dashed lines for the red floor. I don't see it, it's above my head. When I look down, I only see the green surface, no red surface for the ground floor. Winder stairs, the same. Okay, red floor, the whole upper surface of the stairs, and because of the well hole, some portion of the green surface. Uh, this is the cut surface of the steps. Again, some steps are both cut and seen, but the rest, they are just seen. I just transfer them from my plan, and that's it. This portion of the red floor is being cut, that portion of the red floor is being cut. It's been seen here. For the ground floor plan, that's the symbolization of the cut surface of the stairs. This is the seam portion of the stairs with the first step and the middle line, straight line. Rest is above my head, so dashed lines, dashed line for the middle line, dashed line for the red floor. And when I look down, I only see green floor, no red floor. Here, for winder stairs, we need to do balancing. Let's talk about that now. Uh, the balancing is only for this part because as you can see here, these corners get so narrow. When we draw these risers, these corners here, they get so narrow and there is not enough space for our feet to step on. There is a risk of falling down. So we need wider steps. Uh, we need to create something like this by changing their angles so that there will be at least half of enough space for half of our feet. It will lower the risk. That's called balancing, dengeleme in Turkish, and there is a method for that. There are steps, and whenever you design a U-shaped 180-degree turn winder stairs, draw it like that at the beginning. As you can see, there is this flight here. It ends here and it's 90 degree, and you can divide this middle part, this corner part into two or three or four, depending on your need. Here in this example, it's divided into three steps. So this is a 90-degree line in the middle, and three steps, and it goes like that. First draw that, and then follow the steps that I'm about to give you hierarchically. Do not miss a step. Do them as I say, and it will be easy for you. The first step, you need to draw a middle axis, a middle line in the middle part of the stairs, that line. If you have already a step here, just make it continuous towards the beginning of the stairs. Draw a line like that. In the second step, you need to give numbers to these steps that you are going to change their angle. That depends on you. It can be 6 steps, 7 steps, 8 steps. It doesn't matter. In this example, I have 7 steps. I'm going to change their angles. So this is the first step. I write 1. The second step, 2, 3, 4, 5, 6, 8. And that's the last step that I'm going to change. Uh, the first step, as you can see here, it is so narrow. There's no space for my feet to step. So I use my ruler and I just measure at least 10 centimeters like that and specify this corner. And I create this new line that connects this corner, this point, with the middle point of this line here. There's this middle line. I do not change that point. I connect this end point with the middle line and make it a continuous line like that. So my first step has been pivoted. It's been balanced. It's finished. This is wider now. I don't change this middle part. I use it as a pivot point, and I slightly rotate this step, this riser, so that I will have enough space here. And I do it like that. At the beginning, it was like this. I use my ruler to measure 10 centimeters or 15 centimeters or 12 centimeters, depends on you. Create this line here, and now I have a new corner. That corner, I connect this corner, that point, with this middle line and make it a continuous line. That means, and as you can see, I use a different color, so I'm not confused. This red line will be my new balanced riser. It's been pivoted. That's my first step. And I have wider area for my feet to step in. Now, I wrote 7. I determined to, I make decision to balance 7 steps. I need to find the 8th step. That was the 7th step, and this is the 8th step. And I create a line like this and have a cross their intersection with the middle axis line. Find that point and this length here. And as you know, I just make it continuous and have a cross here where they intersect. So I have 2 points. The first one is being created with this first balanced line, their intersection with the middle line. I put a cross. The other one, I have 7 steps to be balanced. I find the 8th step, it's not going to be balanced. I just find it and make it continuous and put a cross to their intersection. So I have 2 crosses, and that will be a radius. I use this length as a radius to draw that quarter circle. I draw a quarter circle here. That's my radius, and it comes from this 2 crosses. I draw this quarter circle, and I divide it equally into 7 pieces because I will be balancing 7 steps. This arc, quarter circle, is divided equally into 7 pieces. First piece, second one, third one, fourth one, fifth one, sixth one, and seventh one. 7 equal pieces. Now, I have points here. I draw straight lines, perpendicular lines, starting from each point to the central line. Start from here and draw a straight line, perpendicular line to the central line here. Do them like that. You need to draw all these lines here, and then now you can connect the middle point of your second step with this first intersection, the middle point of your third step with this other intersection, the middle point of your fourth step with the other intersection, fifth step intersection, sixth step intersection, seventh step intersection, and that's already the horizontal one. If you do that, you are creating wider areas for each one of your steps gradually. This is what we call balancing. And if you mirror it, you will have a balanced, wider steps. Repeat whenever you need to design a wider stairs, do this balancing by following all these steps. Don't skip a step. Do them as I say exactly, and you will have a perfectly balanced stairs. Okay, let's have a look at the U-shaped 3-flight stairs. Upper first floor, I see the upper surface of the red area. I see the whole steps, 2 corner landings, and based on my design, this is the green surface that I see, the ground floor, and a stairwell here. The section I cut through the ground floor. Only this portion of the red floor is being cut. This first flight is being cut. This landing is being cut, and the second and the third one is being seen. And that side of the red floor is being seen. The ground floor, it's being cut here. So the symbolization, everything is else above my head. Straight line for the seen surfaces, middle part, the arrow, dashed lines for the unseen surfaces, dashed line for the middle line, dashed line for the red floor, upper floor, and when I look down, I only see green floor. Circular stairs, upper floor, plan, section. As you can see, only 1, 2, and 3 steps are being cut, and the rest is being seen. I just transfer them one by one. Based on my design, I see this side of the red floor, this side of the red floor, and that portion is being cut. Ground floor plan, symbolization for the cut surface. This is the above part. This is the seen part, middle line with the arrow, dashed line for the unseen parts, dashed line for the middle line with the arrow, dashed line for the sides of the upper floor. And when I look down, I only see red surface. What if we have a basement floor? we did an example only two floors, ground floor and the first floor. But what if we have a third floor? That's the basement floor. We can say that this is 0, 0, that's plus 3, and that will be minus 3. So first of all, in order to connect the ground floor and the basement floor, 0, 0, and minus 3, I need this stairwell. I need to have this gap here. And these stairs, they connect 0, 0 with plus 3. So I need to have a new set of stairs, a new flight to connect minus 3 to 0, 0. So let's first try to understand what changes on our ground floor plan. Again, the height of the cutting plane is the same. It's the eye height of the person who stands on the 0, 0 level. So same things are being cut. This is something that I already draw, the cut surface of the symbolization of the steps, the seen surface of the steps that connects 0, 0 with the 3, plus 3, the whole ground floor, the outside area and everything. But there's a difference now. Because of this stairwell, because of this new gap, when I look down, I see the upper surface of this steps. I see the cut surface, but below that, I see minus 3, the dark green surface of the basement floor. And in between 2, because of the stairwell hole. So that's changed. Now I need to create this new stairs that connects minus 3 to 0, 0. Let's call them blue stairs. If I want, I can change the design of the stairs. I can design a totally new stair, change the form, change the location. I don't need to do it here. I can do it in some other corner. I can change the properties. But if the height of the floors are the same, I can just have the same stairs copied. So these are the white steps that connect 0, 0 to plus 3. I can have the same flight, multiply it to connect minus 3 with 0, 0 and call it blue stairs. Let's call it blue stairs. That means once I cut it here and see the upper surface of the white steps, when I look down, I will be seeing the upper surface of these blue steps that connects minus 3 to 0, 0. And as you realize, first, I had only one thick line to symbolize the cut surface. Now I have two lines, two parallel thick inclined lines to symbolize that there are two flights, white steps and blue steps, two parallel lines. At the beginning, it was just this. One thick line to symbolize only white steps because there was no basement floor, only ground floor and the first floor. So only white steps, one symbolization. Now there are two flights, white steps, blue steps. White steps are being cut, so we still have this line. And I draw another thick line parallel to the first one. There's only a slight gap in between to symbolize that there are a new set of steps, blue steps. They are not being cut, but I do this symbolization so that people can understand. There are two flights of steps. The first one that connects the 0, 0 to first floor plus 3 white steps. The other one, blue steps, that connects minus 3 to 0, 0. Two thick parallel lines. Okay, let's take a closer look. Let's imagine that the upper surface of these steps are blue and the upper surface of this handrail is orange. That means on the ground floor, you can see thick parallel lines to symbolize two steps. So these are the upper surface of the blue steps with their arrows indicating the upper part. So next to these blue steps, I will be seeing the upper surface of the orange handrail. Once it's on the 0, 0 level here, that's the 0, 0 level, it turns 90 degree and then one more time to protect the users to fall down from 0, 0 to the upper surface of these blue lines. And let's imagine the color of the handrail that goes next to the 0, 0 ground floor level is blue. So that will be what I will be seeing. I will be looking at the upper surface of that handrail. And then there are white steps that go upwards that connect 0, 0 to +3. I see the upper surface of these white steps till it's being cut, the symbolization. And next to them, there is this handrail, which upper surface is green this time. So this is what I see. Until it's being cut, I see the upper surface of the green handrail. And in between the blue and the orange and the green, I see -3, that dark green floor, the basement floor, because of the well hole. Okay, this is the uh, ground floor plan. That was the ground floor plan without the basement. Now you can see the difference. Only one thick line to symbolize one step. The rest is dashed. And when we look down, we only see 0, 0. And that was the uh, first floor plan without the basement floor. No cut surfaces, so no thick lines to symbolize. All the steps are being seen. Everything is being seen and no dashed lines. Here, first floor, I cut through here. Steps, they are not being cut. Floor, it's not being cut. Handrails, they are not being cut. Everything is being seen. So I use thin lines to draw the upper surface of the seen surfaces here. Upper surface of the white steps, upper surface of this handrail. It turns like that. It turns next to the first floor area, +3. The same building without the basement. For the ground floor plan, when I cut horizontally, that's the cut surface of the steps. So I use thick lines to symbolize that cut surface. These portion of the white steps, they are being seen. The rest is above my head, so dashed lines, including the middle line and the arrow, and the floor is above my head. So the handrail and the floor, they are dashed line. And when I look down, I only see 0, 0. So this is all 0, 0 level. Now, the same building, the same ground floor, but with a basement. There are blue steps. This portion is the same. I see the same white steps. I cut the white steps. So one dashed line, the same one dashed, not dashed line, sorry, inclined thick line, the same inclined thick line here, but it's multiplied. There is one more thick line parallel to the first one to indicate that there are two flights of steps. And there is a little gap in between. And when I look down, I see the cut surface, the upper surface of the white steps, but apart from that, I start to see the upper surface of the blue steps that connect -3 to 0, 0. So I draw those. The orange one is the handrail next to the blue steps, so it comes from the basement. I see the upper surface of this. When it reaches to 0, 0, it turns and it follows the gap on the ground floor, 0, 0, this dark blue one here, and it turns and it raises up next to white steps towards the first floor as this green surface. and it's being cut. And when I look, this is the 0, 0. It's all 0, 0. And in between, I see -3, that dark green area, basement floor. Okay, so this is an example. Again, please have a piece of paper and uh, do these drawings so that you'll learn the principle so that we can transfer it to your own projects. Okay, let's do one more example, but this time with the U-shaped. And we have a building design like this. Let's start with the ground floor plan. For the ground floor plan, I need to make a horizontal cut that is at the eye level of a person who stands on the 0, 0 level. That's this level. So all these door, window, that door, these walls, and this flight, the second flight, with its handrail, it's being cut. And when I look down, I will be seeing the upper surface of the landing, this first flight of stairs, and their handrail. In order to indicate the cut surface, I use that inclined thick line. This middle line here is one straight line with the arrow, and the rest of the flight and the first floor, it's above my head, so I need dashed lines, including the handrails, this middle line, and the arrow. And when I look down, all the things that I see is the 0, 0 ground floor here. It's all 0, 0. This is all 0, 0. I don't see the first floor. So every level needs to be 0, 0. And the level marks, you need to put them outside and inside of the doors that connect outdoors and indoor environment. So 100 here, 100 there. There's another door that connects outside and inside. So two more level marks, again 00, and at the beginning and at the end of the level difference. So here we have 00 and the landing plus 1.44. Based on our design, our decisions, it's plus 1.44. It's that. And the rest is dashed. We don't see the first floor. We cannot put the level of the first floor. For the first floor plan, again, we cut it horizontally. We look down, we see, we draw what we see. This time, as you can see, stairs, they are not being cut. Handrails, they are not being cut. The first floor, it's not being cut. Uh, the walls, but different windows, they are being cut. So no doors are cut. So I draw the cut surface of the walls, new windows. I draw the whole upper surface of the two flights, including the landing. I draw the whole upper surface of the first floor here. And I see 0, 0, but I don't draw anything because it's way too low. It's way too low. I just leave it as a blank space and I can write gallery space here. Now the level marks, that's important. That's the upper surface of the landing. It's plus 1.44, and that's the upper surface of the first floor. This time it's plus 2.70. That's how we designed it. And this whole area, it's the upper surface of the ground floor. It's 0, 0. You cannot see the first step. It's blocked with the first floor. So no two lines, only the middle line here. Let's draw the AA section. We need plans. First we do the plans, then we draw our section line over the plan and we transfer. We create the section by transferring. First, I transfer the terrace, the ground floor surface, here again the earth, and then I cut through that window, that parapet wall, that window, like that, the roof, like this, and I cut through these steps. These first flight, it's being cut. The landing is being cut. So I need to draw them with thick lines and I need to have a hatch inside. This portion of the first floor, it's being cut. Again, I can transfer it from here, draw with thick lines and dash it. These handrails are being cut, so I need to indicate them with thick layers. And the sorry about that. And the rest of the flights and rest of the first floor and the handrails that are being seen. This inside of the handrails that are being seen. This other flight, it's being seen. This handrail, it's being seen. And the handrail that protects the side of the first floor, it's being seen. This side of the first floor, it's being seen. If you use your line weights correctly, then it will be very easy for the viewer to understand your drawing. The level marks for the cut surfaces here, the level marks for the cut surfaces here, the level marks for the horizontal floor surfaces. We don't give level marks for inclined roof surface here, only the horizontal floor surface. What if there is a basement floor, the same building? What will be changing? Uh, Here, the same ground floor, it's being cut. This is 0, 0 level, and this stairs, it connects the 0, 0 with plus 2.70. So I see its upper surface. I cut it, so one inclined line to indicate the cut surface, but there is a new set of stairs that connects the basement floor with the ground floor. So I start seeing it and I use a second inclined line with a little gap. These are thick lines to indicate that there are two stairs. I see these steps that connects the basement floor with the ground floor, and the rest is based on the design. It's minus 2.70 basement floor, but it's just an empty area. I don't draw anything. I can write gallery space, and this is the 0, 0 level. And the rest is above my head. And that's the basement floor. When I want to draw the basement floor, I need to imagine someone standing on the basement floor on minus 2.70 level. I need to find their eye height and imagine myself that I'm cutting through that eye height. That means that I will be cutting through that earth. And there are shear walls all around the basement floor, and the rest is earth. All these terrace areas, the side walls and the upper terrace, they are above my head, so they need to be indicated with dashed lines. Here, I will be cutting through that steps, one dash, one inclined thick line. I will be seeing the upper surface of this flight here. The landing, it's minus 1.26, the level of this landing. Some portion of this flight, and it's being cut, and the rest is above my head. Now, I don't see these handrails, the side of the ground floor, or these things, so they need to be dashed. And when I look down, it's all minus 2.70, the upper surface of the ground floor. If you want to draw the AA section, again, use your plan, draw the section line here, transfer the information, have a model next to you, and follow which portions of the stairs, floors are being cut, what is being seen when you look towards. So that's it. That's how we do that. The same example or a similar example here. No basement, only ground floor, first floor, and the second floor this time. 0, 0, plus 3, plus 6. So we have a blue ground floor, dark blue steps that connects the 0, 0 with 3, plus 3, first floor, green first floor, orange steps that connects first floor with the second floor +6, and purple or red uh, first floor. You can follow the handrails. It's in between these flights so that they don't fall down, and it protects the side of the second floor. Also, it's next to this landing. It comes like that, and it protects the side of the first floor, and it protects the side of the landing. It raises up with the stairs, and it protects the side of the second floor. So let's take a look at the ground floor this time. Ground floor, when we cut through here, the symbolization for the cut surface, we see dark blue steps. And when we look down, it's only the blue ground floor, 0, 0 level. The rest is above our head, so it's all dashed. We see the landing, this landing here, it's plus 1.50. That's the ground floor plan. When we want to do the first floor plan, it means that we will be cutting through that orange steps here, and when we look down, we will be seeing the yellow first floor, the upper side of the orange steps, this landing plus 4.750, some portion of the orange steps, it's being cut. And when we look down, we will be seeing the upper surface of this dark blue steps, two steps, two flights of stairs, so two lines, a little gap in between, two thick lines and a little bit gap in between. And here we will be looking at +3 green floor, and in between here we will be looking at the blue floor. It's ground floor, 0, 0. And these are the upper surfaces of the handrails. Now, the second floor. It's being cut here, as you can see, no steps, no handrails, no floors, they are not being cut. Everything is being seen. When we look down, we see the upper surface of this red floor all around. It's +6. The upper surface of these orange steps, it's not being cut, so no thick inclined lines, only seen surfaces. This upper surface of this +4.50 landing, this upper surface of the flight, here, based on our decision, we only see partially this green floor of first floor, +3, and in between, we see the bottom, the upper surface of the ground floor, 0, 0, here. Ground floor plan, first floor plan, second floor plan. If you want to do the section, AA section, do the plans first, arrange them like that, draw your section line. It cuts through this first flight of the dark blue steps, first flight of the orange steps, and some portion of the red floor, yellow floor, and whole blue floor. Transfer them like that, and then draw your sketch. You cut through the ground floor, 0, 0 level, blue floor. These whole dark blue steps, they are being cut with the landing plus 1.50 here. And the other flight, it's been seen. You cut through this yellow +3 floor here, and you cut through these orange steps with the landing plus 4.50. The rest of the orange steps, they are being seen. You cut through that red floor +6 here and here. And when you look towards, you see this side of the red floor with thin lines, it's been seen. You see the side of this yellow floor, first floor +3, it's been seen. And you see the side of this handrail going upwards and next to the first floor and going upwards and next to the second floor, and here it's being cut also. That's the AA section. And BB section. BB section, its position is different now. We don't cut through the stairs, we cut through the floors. First, draw your section line here and transfer it. Use your AA section. As you can see, it cut through the whole blue surface. It cut through the whole yellow surface, first floor +3. It cut through the whole red surface, second floor +6. And that's the only things that are being cut. The rest is being seen. When I look towards this direction, I see the front view of these dark blue steps here. It's the landing, and the rest is going up. I don't see the steps. I see the lower surface of the stairs. So the steps, they are dashed. And this handrail is going up and turn, and the rest I cannot see it. Same with the orange steps. I see the front view of the orange step. The rest, the lower side of the stairs, the steps, they are dashed. As you can see here, this handrail comes, turns, raises, and then turns one more again on the side of this yellow first floor, and it raises uh, parallel to the orange steps, and it turns next to this landing and continue to be raised, and then it protects the side of the +6 floor like that. If you take a closer look, that's how you see the handrail, this portion here. It's been seen like that. Spiral staircase like this. This is the first floor plan, the AA section. Now let's do one example with the spiral staircase, and that will be the last example. Let's imagine we designed the same building, but this time there is this spiral staircase. Basement floor, ground floor, first floor. Dark brown, gray, light brown, or let's say orange. I designed the stairs first that connects the dark brown basement with the gray ground floor. And there is this middle part, the center. In order to draw the basement floor, I cut through these steps, the walls, and the earth itself. So the middle column is being cut. That step is being cut. So in order to indicate it, I use that inclined, very thick line. This part, it's been seen. The middle line, it's continuous with the arrow, and the rest is above my head. So they are dashed, including the arrow. And when I look down, I see -2.70 dark brown basement floor. It's this. Let's add some guardrails and handrails. As you can see, it's being cut. So since that level, I see the upper surface of the handrail. This symbolization that includes the cut surface of the handrail, and the rest is above my head now. I see them with dashed lines, and here it's the side of the gray floor, 0, 0 level, ground floor. So the handrail follows that side, and there is this portion of the handrail that protects the user from falling down, so it's been dashed. And when I look down, I only see dark brown surface. In order to connect the gray floor with the light brown floor, I need a new set of stairs. I can multiply the same stairs if the floor height is the same, so that's what I did. Uh, let's call them red steps, and the previous one can be the purple steps. Red steps are to connect ground floor, gray floor with the first floor, this light brown floor. And we have a new handrail that protects the user. Let's draw the ground floor this time. I cut through here. As you can see, at this level, red steps are being cut. So that's what I need to do. When I look down, I see gray floor. It's the 0, 0 level. I see the upper surface of these red steps till they are being cut. I symbolize it with this thick line. Since there are two steps, I need a second thick line with a gap in between. And when I look down, I see the upper surface of these purple steps. And in between, I see dark brown basement floor, minus 2.8. That's the upper surface of red steps. This is the handrail that protects the side of the 0, 0 gray floor. Next to red steps, we have dark blue handrail that raises upwards, and it's being cut also. And when I look down, this is all I see, the gray 0, 0 level. These are the upper surface of the purple steps that connects the basement floor with the gray 0, 0 level. Next to them, there is this green handrail that comes from the lower side. And when it reaches to the 0, 0 level, it turns color. The color is turned to red now. It protects the side of the 0, 0 level. And here, when I look down, that's what I see. I see the basement floor, upper surface of this basement floor, dark brown surface. Now let's do the first floor plan. We elevated the cutting plane. We look down. As you can see, no stairs are being cut, no handrails are being cut, no floors are being cut. Everything will be seen. So this is what I will be drawing. When I look down, I see this light brown first floor plus 2.70. The whole upper surface of the red steps, the dark blue handrail next to these red steps, and when they reach the first floor, they continue as brown handrails here and here so that the users, they don't fall down. And when I look down, that's what I see, the basement floor. Two flights down, two floors down, uh, minus 2.70, dark brown basement floor. So that's the basement floor. I only see dark brown floor surface, some portion of the purple steps till they're being cut, some portion of the green handrail till it's being cut, and the rest is above my head, including the sides of this gray floor and the handrail, the red handrail, so they are dashed. That's the basement floor plan. This is the ground floor plan. I see some portion of the red steps. It's being cut. One thick line, a second thick line to indicate two stairs, some portion of the purple steps, it's been seen, the green handrail, it's been seen, the gray 0, 0 level, it's been seen. Next to this gray 0, 0 level, we have red handrails, straight handrails, they are being seen. And in the corners, I see minus 2.70 upper surface of the basement floor. Here, it's been seen. On the basement floor plan, only one stair, so one thick line to indicate the cut surface. On the ground floor plan, red steps are being cut, so one thick line to indicate that cut surface, a second thick line to indicate there is one more step coming down from up, this purple one, two inclined surfaces. That's the ground floor plan. And the upper floor plan, stairs are being not, they are not being cut. So no thick inclined line. Only seen surfaces of these whole red surface, this dark blue handrail, the light brown upper floor, first floor plus 2.70, these brown handrails, straight handrails, and in the corners, I still see minus 2.70 based on floor. That's the first floor plan. Do the plans first, and then place them like that to draw the section, AA section. And you need to transfer each step one by one. As you can see here, if you place your AA section line here, it means that first step is not being cut. This is not being cut. The second step, it's not being cut, but the third step is cut like that. The fourth is being cut like that. The fifth is being cut. Sixth, seventh, and that's it. The rest is not being cut. It's only seen. So you need to transfer them one by one. Something like this. Just imagine only two steps. I'm going to have a simple example using these two steps. Draw the section line. Their intersection will give you the cut surfaces. So these two steps, they are being cut. That's the floor. First, I transfer the cut surface of this fourth step, that one, the fourth step, sorry, this third step, this small portion, and the fourth step, the upper one, the cut surface of the upper one, fourth step. These are cut surfaces. They need to be drawn with thick lines. And now I move on to the scene surfaces. Scene surface of the third step, lower one. I see this corner, that portion is being cut, and the rest I see, and this corner, it's at the back, so it needs to be dashed line. I can do the same with this back corner. I can use dashed line to indicate it's at the back, this back corner. I can do the same with the fourth step. I can transfer this corner, and that corner. This is the portion that I see. This corner is blocked, so dashed lines. That corner is at the back, so dashed lines. You can do the same with all the steps, one by one. Uh, Here, you can easily see that the cut surface of these purple steps, the cut surface of the green handrail, the rest is dashed at the back. And when I look towards, I see the front view of these handrail and guardrail. Same with the red steps. Cut surface of the red steps, cut surface of the blue handrail, and seen surface of the blue handrail. Here I cut some portion of this red handrail next to the ground floor, and I cut this brown handrail next to the first floor. That's it. If you use correct line weights, and if you hatch them to indicate, to emphasize the cut surfaces, you will create a drawing that is almost three-dimensional. The viewer will be looking at almost a three-dimensional view. You can do that by transferring it from your plan. So that's the end of the video. Thank you for listening. I know it's been the longest video, but I wanted to give you everything in one video, including the drawing and design properties and the lecture information, so that whenever you need, you can watch the video. You don't have to watch it all the way through, but you can just jump to the related section, and please use this video whenever you need during your project lessons or during your internship. It hopefully it will help you a lot. Okay, thank you for listening. See you at the next video, hopefully.